All right, welcome to our next lesson, which is going to be on one of the applications of trigonometry, and that particular application relates to bearings, or you might even think about this as navigation. So we have, for this example, a ship that's going to travel due south for 6 kilometers, and then on a true bearing, which sort of measures where it's heading, for 10 kilometers, and the bearing is 120 degrees true. So we'll be able to construct a diagram to show where that ship's travelled to now. So the first thing we're going to do is start with that diagram, and then we're going to look at these two questions that we need to answer. The first one is how far east of the starting position is the ship, and then we want to find how far south of the starting position the ship is. So to set this up, we're going to start with the initial position of the ship. And what I'm going to do is I'm just going to make a little compass here, and that's going to be the starting position. And of course, this would be true north. Then we know that this ship travels due south for 6 kilometers. So that means it's going to go straight down here for 6 kilometers. And then I'm just going to make another small little compass mark there, just so that we can judge where 120 degrees is. So 120 degrees true means we start at north and we go around 90 degrees, takes us to this horizontal line, and then another 30 degrees past it, and the ship's going to travel on that bearing for 10 kilometers. And it's going to reach its final location just here. And I'm just going to put another compass point there, just so that we can keep track of where all these lines are pointed. So we'll label this. This first distance was 6 kilometers due south. So I'm going to put 6 kilometers there. And then we knew that it was 10 kilometers on the bearing of 120 degrees. So I'm going to put 10 kilometers just here. So that's how far that length of the journey was. So now we've got our construction, we can start to think about how do we answer these problems. So the first question is how far east of its starting position is the ship? So how far east is this distance going straight across our diagram? So this is north-south, west-east. So how far east is how far in this direction did the ship end up? So that's how far east is our question. So we can represent that as a straight line, and that would create a right angled triangle. If I take the line directly east and then directly south again, we now have a right angled triangle that we can begin to deal with. And that's quite useful because if we have a right angled triangle, we've got plenty of knowledge from trigonometry about how we can calculate things. So we've got that this is 10 kilometers, and that will be the hypotenuse of this triangle just here. And what we also know is that the angle that went from here to here was 120 degrees. Now there's a little right angle in there, meaning that inside the triangle we've gone 30 degrees further around than that east-west line. So we've now got a right angled triangle with an angle in there, and we've got the hypotenuse's value. And how far east could be represented by this length here, which I'm going to call x. So if we just quickly think about what we've got the angle, we've got the adjacent side length, which we're trying to find, and we've got the hypotenuse. So if we have a, h, and an angle, that means we can use cosine. So we're going to use the relationship cosine for this question. So cosine of an angle, we know is equal to a divided by h, or the adjacent over the hypotenuse. So for this particular question, the angle is 30 degrees, so we can drop that in there. And we can say cosine of 30 degrees is equal to the adjacent length, which is the x, the unknown, and that also represents how far east our ship is, over the hypotenuse's length, which is this 10 here. So we're going to have x over 10. So therefore, if we multiply both sides by 10, we could get x by itself, and we'd find x equals 10 times cosine of 30. And now we want probably to answer this question to 2 decimal places. So we're going to use a calculator to evaluate that. So if you get your calculator out, we want to on here go into the main menu. And what we want to do first is check that we've got degrees as our setting down the bottom, and then we just want to plug in 10 cos of 30 and see what that works out to be. So bringing up the keyboard and going to trig, we can find our sine, cos and tan functions. And we're just going to type in 10 cos 30 and close off that bracket. When we hit execute, we actually get a standard value or an exact value of 5 root 3. But we'll do both of these questions to 2 decimal places. So I'm just going to tap on that and turn it into a decimal. And we find to 2 decimal places, that's 8.66. So that's the answer that we're going to have for this question. So x is equal to, and then we know that this is 8.66. And as we're dealing with kilometers, we can put those units here. So that is the answer to part A of this question. Next up, we want to find how far south of the starting position the ship is. So how far south is going to be 6 kilometers and an extra little bit here. So this extra little bit I'm going to call y, just so we have something different to x. And now we've got the opposite to that angle, the angle and the hypotenuse. So the relationship that we can use now, if we've got the opposite, the hypotenuse and the angle, is actually sine. So just here we're going to write out that sine of an angle is equal to the ratio of the opposite length over the hypotenuse's length. And then just as we did for this question, we're going to substitute in what we know and then use the calculator to find that value. So we're going to have the angle still being 30 degrees. So we're going to have sine of 30 is equal to the opposite, which we're going to call y, divided by the hypotenuse's length, which is 10. So putting that into the calculator, this time I'm going to show you that from this step we could just solve for y. So in a moment we're going to have exactly what y equals. So on our calculator, we want to go back into the main menu. So hopefully that's still up in front of you. And now we're actually going to type out an equation. And the equation is sine of 30 is equal to, and then we're going to have y divided by 10. And we could go interactive, equation equality solve. And the variable we want to solve for this time isn't x, but y. So we're just going to put that in that box and hit OK. And it gives us y equals 5. So we don't actually need 2 decimal places for this question. That exact value is exactly 5 kilometers. So just so you know, you could have found y by just typing in 10 sine of 30. So that is multiplying both sides of this equation by 10. Or you can use the solve feature on the calculator to find what y is. And we found that y equaled 5. So if we put that in here, we get y equals 5. However, that's not actually the answer to this question, because the question says how far south of its starting position is the ship. And we already had 6 kilometers due south, and then another 5 kilometers here, which gives us, therefore, it is 6 plus 5 equals 11 kilometers south. So that is our answer. And this question was, of course, how many kilometers east? And because there wasn't any other east traveling involved here, it was just all from here to here, then we knew that that value of x, which was 8.66 kilometers, was the only value we needed. For the second question, we had a journey or leg of the journey that was 6 kilometers due south. And then when it was traveling along this bearing of 120 degrees, just down here, it traveled another 5 kilometers further south, giving a total of 11 kilometers south overall. So we're going to continue this example in just a moment. We're going to look at parts C and D. All right, so the next 2 parts of this question are going to ask us, first of all, how far the ship is from its starting position. So if we considered a direct line from its start to its finish. And the second bit is going to be what bearing would the ship need to take if it wants to return directly to its starting position. So if it wanted to go from here straight back to the start rather than going back along the pathway it took, if we just went straight from the end position to the start position, what bearing would be required? So for the first question, how far the ship is from its starting position, we're going to use information we had from the previous 2 parts of the question. So we're going to refer to them now if you're wondering where this comes from. So we're going to draw a little diagram that represents how far south and east the ship was. So the ship started and ended up a total of 6 plus 5, which was 11 kilometers south, and it ended up 8.66 kilometers east of its starting position. So we can make that a right angle because that's exactly south and exactly east. They are 90 degrees apart. And the length that we're really interested in finding here, in terms of how far it is from its starting position, is the length of this line here. So this one, just because we've had a few different letters already, I'm actually going to call this H. So that's a little h. And that actually stands for the hypotenuse of that triangle. So we have a right angle triangle. We want to know the distance of h. So that's a question where we could actually use Pythagoras' theorem. So that's why I've conveniently used h there, because we know that h squared is equal to a squared plus b squared. So if we do a line of substitution, then we're going to use the calculator to find this correct 2 decimal places. H is unknown, so we would say that therefore h squared is equal to a squared, which might be the 8.66 squared, plus the 11 squared. And now from here, we can type this into the calculator and solve for h. So we're going to have, from variables, h squared is equal to, and we're going to use the unrounded decimal from above. So we're actually going to drag down the 8.660 ... And we're going to use all of that in our answer. And we're going to square that plus the 11 squared that's also part of our rule up there. From here, we highlight all of that and go interactive equation inequality solve. And we want to solve that for the variable h. And if we click OK, that will give us an answer. And that answer actually turns out to be an exact value. So that exact value is 14 kilometers away from its starting position. So the answer to part C is therefore the length away from the starting position is going to equal 14 kilometers. So we didn't actually need the instruction in this case to 2 decimal places. So I didn't need to put that there, so I apologize. We actually get that this is an exact value of 14 kilometers away from the starting position. And now the final question here asks, what bearing would the ship need to return directly to its starting position? So if we look back at this diagram we have up here, we want the bearing, which is the angle from true north, that it would need to travel so that when it heads in that direction, it would reach the starting position. So whatever that angle is, we need to find it. And part of that angle, the angle just between the west-east compass line and that blue line that I've started to draw up towards its starting position, that angle there is actually wedged in to this diagram. So I can put an angle there that we need to find to be able to answer this question. Once we know that angle, we just need to add 270 degrees to it and we should get our bearing. And that bearing, I'll guarantee for this one, will need to be to 2 decimal places. So I'll just write that there for our reference. So to start with, we're going to use this diagram to find the little angle here. And what we've got now is we've got the opposite, we've got the adjacent, and if we have O and A and we want to find the angle, we can use tan to do that. But in particular, we can use inverse tan, so that theta, the angle we want to find, is equal to tan inverse of the ratio still of O over A. So what we're going to do is we're going to find that the angle theta is going to equal tan inverse, and the opposite is the 11 kilometers to that angle, so that's opposite. And then the adjacent is the 8.66. But in the calculator, we'll definitely use the unrounded value there to help us out. So that's our next job, is to find what that equals to perhaps 2 decimal places. So on the calculator, we need to go once again into the main menu, and we're going to go to trig and find tan inverse. And then we're going to put a fraction there, and we want to drag down the unrounded 8.66, and that'll go on the bottom line. And then on the top line, we're going to drag the 11 in, or just type the 11 in. So our input is tan inverse of 11 on 8.66. And when I hit execute, as a decimal, we get 51.78 or 79 if we do the rounding now. So our answer to the first step in this process is going to be 51 point, and it was 7, and because it's 8.6, that goes to 7.9 degrees. So we know what this angle is, and we discussed before that to get the true bearing, we do 90, 180, 270 plus the 51.79, and that will give the bearing that we need. So therefore, the bearing that we need is going to be 51.79, and then we're going to add on to that 270, and our calculator tells us that that is 321.79. So 321.79 degrees, and that's the true bearing to 2 decimal places that the ship would need to be able to get from where it ended up back to the starting position. So that wraps up that example. There's a fair bit to digest there, but obviously going and getting some practice of that now is going to be very, very beneficial. And remember that there was 4 different things shown in this question that you'll be able to use and apply in your set exercises. So good luck with the rest of the lesson.